Okay, Algebra, I'm having a hard time finding a spot to tape this. It seems like it's really light upstairs and it's just bleaching out everything. So we're down here in the basement. See my bare rug here? You can see our ping pong table. Yep, it's the basement. Anyway, today we're going to do lesson 6 on adding and subtracting rational expressions. And I really just have two words that are the key to this whole topic. Common denominators. Okay? Anytime you have any kind of fractions, whether it's 1/2 plus 1/3 or anything more complicated than that, you have to get common denominators. And usually the way you do that is you find the least common denominator. And in this case, 2 times 3 would be 6. That's the least common denominator. So I'm going to multiply this by 3 and this by 2. You remember how to do that, right? All right. Well, if we make this more complicated, it's going to be the same thing. Sometimes these are going to start off with common denominators. For instance, 1 over, let's say, n plus 3 minus 2 over n plus 3. You see they already have common denominators. So it's basically this minus this over that common denominator, right? So -1 over n plus 3 would be your final answer. I hope you see how that works. Sometimes there's going to be like almost a common denominator, but in this case, what if it was instead of n plus 3, sorry, let's do minus here. Let's just change this up a little bit. If it was n minus 3 and this one was 3 minus n. Well, you can see that they're almost common denominators, except one is basically like the inverse of it, or the opposite. If everybody here became -3, and then that'd be plus n, we could reverse that, and it would be a common denominator. So basically, if we multiply this whole fraction by -1, sorry, -1 on top, -1 on the bottom. So we can do, why don't I just write this in here? -1 times this over -1 times this. Everybody's going to turn the opposite here, and it's going to be like that. And this will become -2. Or basically what I can think of it as, instead of subtracting, is I'm just going to make everybody addition. Okay? Sorry if my handwriting is messy here. I'm going to have plus 2 over n minus 3. And now I have common denominators, and I can add these, and you'll get 3 over n plus 3. Okay? Does that make sense? All right, let's try a tiny bit more complicated. What if I had, say it was 6 over n plus 3 plus 2 over n minus 3. They're not the same. I can't make them the same by doing the old inverse trick. So what I have to think to myself is, what's going to be the least common denominator? And kind of like my example at the beginning where it was 1/2 plus 1/3, the least common denominator in this case is going to be this multiplied by that. So what this one needs is it needs an n minus 3. Remember, you can't just have it on the bottom, you also have to do it on top. And what this one needs is an n plus 3. And again, I have to do on the top. So basically, I've multiplied by 1 here, I've multiplied by 1 here. Sorry, it's this whole thing times n minus 3, and it's this whole thing times n plus 3. So now, the bottom has common denominators. The top is going to get kind of messy here when I expand it out. Due to the distributive property, it's going to be 6n minus 18 And here I have positive 2 times this. 2 times n plus 3 is going to be 2n plus 6. I can combine those, and that would give me, can you see this? 8n, 6n and 2n, and negative 18 plus 6 minus 12. Let me kind of subtract, get rid of that so you can see better. And this is going to be over the common denominator, which was n plus 3 times n minus 3. Of course, you could multiply that out, do FOIL, and expand it out, but I don't think it makes it any more simple, so we're just going to leave it. Okay? So this would be your final answer for that original problem. Okay, so no matter what you do, you have to get a common denominator. Sometimes they'll be simple. Sometimes you can just massage it a little bit and get a common denominator. And sometimes you have to actually multiply them together and expand it out and get common denominators. Then you can add or subtract them just like you normally would, and you'll be done. Okay, I hope that works for 11-6.